No? Okay. Well, good afternoon, everyone, and welcome. It's a great honor to introduce Charlie Bolden, who's the 12th Administrator of NASA. General Bolden has been a great advocate and supporter of ISMS for many years, and it truly is an honor that you're taking time from your busy schedule to join us. Really, General Bolden needs no introduction. But I've been instructed to give one at any rate. So, he's a veteran of 4 space flights, pilot on 2, commander on 2, 34 years as a Marine. I think 14 of those as an astronaut.
That's good.
I'll stop there. General Bolden, thank you.
Thanks very much, Jeff, and thanks to all of you. I think I'm the last thing between you and the reception. So. No, there's something else. There's another panel, 2 more panels. Man, I need to update my book. Okay. What I thought I would do was I wanted to bring you sort of a summary or an update of where NASA is on our exploration program. And in so doing, solicit questions, comments, criticisms, anything else you do, because I have a lot of criticism myself about our program, and I just want to know whether my criticism is shared by others. First of all, let me thank, I want to thank Dr. Ushikoff and Dr. Scott for the panels this morning. They were very, very helpful to me. They were very, very informative to me, because usually, Nessa, I think they want you on the podium. She's busy. That's all right. You can come on up. I'm going to move my stuff.
No, we thought that.
That's okay?
At 2, yes.
I know. I told them I'd be done in time for the panel. But I thought, Shannon, are you here? Shannon Lucid's outside. Shannon told me that I could share some thoughts that we were exchanging while we were outside just before lunch. And it's something that I want you to think about. Shannon was saying when she was, and I think, does everybody know Shannon Lucid, by the way? Personally, probably not, but everybody knows her by reputation. Shannon was saying, much like me, when she was growing up, she dreamed of exploration, and she dreamed of going to Moon and Mars and all that kind of stuff. And she was absolutely convinced that we would figure out a way to get humans to Mars. What she was equally convinced of was that she would never have an opportunity to do that because she was female. And you got to remember when Shannon and I grew up and places where we grew up. And she said, I find it ironic that the world is turned on its ear. We appear to be standing still in our effort to get to Mars. And society has so changed that we now have women and people of color who are poised to go to make the journey if we have the courage to make the journey. And I told Shannon, I said, it's interesting that you would observe that, because I am, for those of you who know me personally, you know that I have always been somewhat naive, very optimistic, sometimes rosy, like rose-colored glasses optimistic. But I am passionate about things in which I believe. And I really believe still that humanity is on its way to Mars and places even more distant, maybe. And a lot of it's going to be done in our lifetime if we don't shirk away from the opportunity and the responsibility to do it. So what I thought I would do would be to tell you, because I've heard a few comments today on the panels, in the discussions out here and around the table, that leave me a little bit concerned, and I want to share my concerns with you. The roads. I thought the roadmap discussions were very, very, very important, because they gave us an opportunity to see how 2 principal partners in what we're doing today have very, very dissimilar ideas about how you use a roadmap. Or if there is such a thing as a roadmap. I was very encouraged. I think it was Mike Barrett that said, as an investigator and an astronaut and a scientist and the like, he loves roadmaps because it gives us something from which we can diverge. As a Marine, I love roadmaps. We call our roadmap a war plan. And in the Marine Corps, it is law, rule. It is just a fact of life that no plan survives crossing the line of departure. But what is really, really, really important is that you step off and you cross the line of departure, and then you adjust as you go. If we sit around and we ponder how we do this, we could do this forever. We could do it into another generation of people. I told Ellen Baker as I was sitting out there, I'm very encouraged because this is not my ninth ISMS, but it's almost, because I think I was here when we thought about getting started, almost, with Dr. Alfred and Mr. Abbey. They have been the lifeblood of this summit. They have been the two people who have persisted against all others and all detractors and said, this is really, really, really important. And what has been important to all of us who have been involved, whether assisting them or whatever, is to see all of you come to town from all of your disparate locations and give of yourself for these 2.5 days, because it really is important. Let me give you my perspective as the NASA administrator. And that's, I tell people that I am privileged, I am blessed, to be quite honest, to run the greatest space agency in the world. Now, people will take issue with that, and that's okay. If there is somebody in here who doesn't think theirs is the best, then I want to talk to you. But I happen to believe that I run the best space agency in the world. And we have something that's called the heads of agency. And I think most of you who associate with the International Space Station have at least heard that term. But with reference to the space station, the heads of agency, and we try to meet quarterly, we generally don't, but we try. They're the heads of the 5 dominant agencies that put money into the International Space Station. And there was Cosmos, the Russian Space Agency, NASA representing the United States, JAXA representing Japan, the Canadian Space Agency representing Canada, and then the big kahuna, believe it or not, the European Space Agency, which today has about 22 member nations, 15 of whom or so actually financially invest in the International Space Station. And somebody mentioned it this morning on one of the panels. It said, the reason I feel privileged and the reason I feel a great sense of responsibility is because I ask the question all the time. Julie will tell you this. When I sit at the heads of agency meetings, and generally the U.S. is kind of halfway considered to be the, whatever you want to call it, the informal head. And you go in and you try to pull everybody together and you try to make sure that whatever agenda we have gets taken care of. I am very careful to ask at every meeting, okay, where do you guys want to go? We're all saying we want to explore, but where do you want to go? And without fail, I haven't had an answer that's been any different in my 6 years so far as the NASA administrator. Every single time they say, we're going where you go. And that is very, very, very important for any of you who represent. Anessa, I don't know whether you're fully getting what I'm saying here, but she and I, we commiserate all the time, and I think she's equally as disappointed about some things as I am, and that is that we are not as far along as we should be in internationalizing the International Space Station. We have this. We go and we're a mutual admiration society every year, because Anessa and I say the same thing. We are not as far along in internationalizing the International Space Station as we would like to be. And what do I mean? I get a lot of questions all the time from my employees at NASA and from people around the world who write me because they hear me speak all the time. And I always talk about no one nation is going to Mars. It is going to be an international collaboration. In fact, no one nation is going to go back to the surface of the moon. It is going to be an international collaboration. And I'll get on that later, because we do have different, when you look at what our desires are and what our primary goals are, we have different goals. And that's good, because that's what makes the team stronger. But if we are not focused on at least the general direction we're going to go. Somebody mentioned direction this morning on one of the panels, you may remember. If we're not in agreement in the general direction we're going to go, then we're in trouble. I think we're in good shape, because We have the collaboration of 20 some odd nations that have been getting together over and over and over in a number of different international fora. And we have actually produced a document called the Global Exploration Roadmap. And there are 12, 13, I say signatories. Nobody ever signs anything. People don't like signing things. But there are 12 or 13 nations who have agreed that this is where we think the world is going in exploration. Mars is the ultimate destination for humanity, and there are other places that we need to go in order to facilitate our getting to Mars. Bonnie and I had a long conversation last night. She and I happen to be of disparate minds about where you go first. I am one who believes you pick the farthest place you want to go, and you set your course there. And in getting there, you're going to go by some incredibly interesting places. Somebody who wants to sail around the world on a sailboat, I've never done that. Anybody ever circumnavigate the globe in a sailboat? I mean, I've circumnavigated the globe, but I have never done it. That's on my bucket list, to circumnavigate the globe. People who circumnavigate the globe set out to come back to the place from which they started. And if they say, okay, I'm going to go around the world and I'm going to Jamaica from Miami, and that's the only place they have in mind, they will go to Jamaica and they may not go very much farther. This is philosophical, okay? I'm just talking philosophy here. I think we're going to Mars right now. I don't say that we're not going any farther eventually, but I think right now we're going to Mars. You all are working your little butts off every single day to make it possible for humans to go to Mars. And hopefully you're not doing it because somebody told you to do that. Hopefully you're doing it every single day because it's a passion. And you believe that in doing so, we will make this planet much better than it's ever been. Tom Stafford mentioned it when we were talking to Scott and Misha. We just wish everybody had an opportunity to spend one day on the International Space Station. Because that's the way we ought to be working down here. That is the model. A lot of people have tried models. That one works. And it has worked for 15 years. And that's really, really, really important. So how are we planning to affect this journey to Mars? We're committed, for one thing. And so anybody who doesn't think NASA's committed to going to Mars, you're mistaken. We are focused and committed to getting to Mars. We've got a couple of places that we're going to touch before we get there. We hope that we're going to put humans with an asteroid. Some of you think that's hokey or folly, and that's good, to be quite honest, because you'll probably be the ones who will give us the necessary final steps that we need that's going to make it successful. Those of us who believe we're going to do it, we're probably missing something, to be quite honest. We're going back to the surface of the moon, and we're going to do that before humans set foot on Mars. Why do I say that? I say it because some of you represent countries. Anybody who's not from the United States is representing a country who has never done that. That's a big deal. Think about it. If you come from a country that has never had a countryman set foot on another body off this planet, it's a big deal to be able to say you did that. Today, there are 5 nations, maybe a couple more, who are physically on the surface of Mars. Up until Curiosity landed, there were 2 nations that had actually, and I get in an argument with my British friends, but there's been one nation that has successfully landed something on Mars. That's something that landed and rolled away from its starting point and did some stuff. And so in Curiosity, we took partners with us in terms of their instruments, the weather station. How many of you know about the weather station on Curiosity? It's this mast that sticks up. It is the weather station. Who did the weather station? Anybody know? Come on. Somebody knows. Barbara, you know. Bonnie, you know. Anybody in here from Madrid? Madrid, Spain. The Spanish Astrobiology Center did the weather station. So, the anemometers and all this other kind of stuff That comes from our Spanish partners. The radiometer, or we call it Dan, or they call it Dan. Who did Dan? The Russians. So there are instruments on Curiosity that now there are at least 5 nations, 6 maybe, who can say we are physically operating on the surface of Mars. And that's really, really, really important. And we refer to things like Curiosity as precursors for humans going there. We're getting ready to launch something next year called Insight. It's a lander. It's going to land on Mars' core several feet into the Martian surface, and we'll have an opportunity to look at a piece of the planet that we've never seen before. Getting some information from the interior of the planet. That's not an American mission. It's an international mission. We have partners that are participating in that. We recently, earlier this year, announced the scientific missions that are going to be on Mars 2020, which is the follow-on to Curiosity that's going to launch in 2020. International collaboration again. So everything we do has been and will be international collaboration. We've got entrepreneurs, other nations, colleges and universities that want to put things on the surface of the moon. And many of them want to put things like us on the surface of the moon. My Russian counterparts this morning talked about their roadmap, which some of them say they don't like roadmap, but it's a roadmap, and or whatever you want to call it. But in that roadmap was putting humans on the moon. If you talk to our Chinese colleagues, with whom I can't talk, unless some of you are in the room, they talk about putting a human on the moon. And to me, that's very, very, very important, because when we go to our when we go to the heads of agency meetings, I tell them every single time, I said, look, we can get you to where you want to go. I can get you to cislunar space, because we're going to have a rocket one of these days, not very long from now, that'll get anything to cislunar space. And so I need some people to go with me who are going to provide the wherewithal to get from orbit down to the surface. I only want one thing in return: at least one American astronaut on the crew. That's kind of the way we do it. And that's the way we have operated the International Space Station for 15 years now, and that's the way I think, we should follow that model as we collaborate to put humans on Mars and back on the surface of the moon. And here in the United States, we're famous for yelling, you can't lead from behind. I disagree. You can lead from wherever you happen to be, because you lead through inspiration, and you lead through your support, and you lead through facilitating the success of people. I tell people all the time, they ask me, what in the world do you do as the NASA administrator? And I tell them my number one job is my people. I try to facilitate the success of the 18,000 employees in NASA, and I try to make their lives better every day, and I try to keep all the trash. That's not a good word to use. I try to keep all of the distractions away from them in Washington, D.C., and the distractions come from both ends of Pennsylvania Avenue. They come from all over the place. And so if I can keep the distractions away so that they can do their jobs, people like Julie or Bill, and I think they're doing them incredibly well. And so I do accept a little bit of credit for allowing them to do what they do by trying to keep the distractions away. And that's really, really, really important. Getting ISS extended to 2024 was critical for us. And it was critical for a couple of reasons. For those of you in this room, it's critical because that's more time to put your experiments in place to help us understand better how the human body functions in the microgravity environment of space, and ultimately, if we can model it, how it might perform in something less than 1G. Because there are some problems. I'm not a doctor at all. I'm not a scientist. But there are some problems, for example, the intracranial pressure problem that we have. I think at some point we've got to get into a less than 1G environment to understand a little bit better as to whether that's a phenomena that's primarily due to microgravity, or is it just something less than 1G? Are we going to experience that when we get, Bill, when we get to Mars? Are we going to have it get even more intense or something? And if we go to the surface of the moon for a period of time, I don't think we need a lot of time to get data, but every piece of data that we get helps us. So ISS life extension was really, really, really important. For people like Brewster Shaw, Brewster's heard me say this before. He says I unjustly give him credit. I give him credit for saving commercial crew. That's because Brewster used to work for the Boeing Corporation. And I tell people all the time, until the Boeing Corporation, until a big company here in the United States decided that they were going to step into the fray about commercial crew, I don't think it was going anywhere fast. You've got to have somebody with really big influence that the American public and Congress believes in, or they're not going to support it. So you know, when big aero, old aero, if you want to call it, since they're not, Boeing may call themselves new space, but they're not. They're good old space. You know, the new space guys, the ones that are pushing all of us, to be quite honest, the Elon Musk, the David Thompsons to a certain extent at Orbital. David's not a new space guy at all, but the way that they do business is a little bit different than the way that the classic aerospace companies do it. And so we really need them. The most important reason for extending the space station to 10 more years from a commercial standpoint is they actually have boards of directors that they've got to convince that they made the right choice and that there is a return on investment in doing that. And so 10 years of operating in low Earth orbit, carrying people, carrying cargo, that's enough to demonstrate to the boards that, yeah, we made a smart choice. And there is profit to be made here. The people who support us at NASA, our contractors, they don't do it for free. And if there is no return on investment at the end of the year, then they don't support us very much longer. So 10-year extension for the International Space Station really helped there. We are buying down risk every single day on station, buying down some of the medical risk. I think most of you know I look at two matrices almost every day. One of them is a technical risk matrix. The other one is a medical risk matrix. And Bill, I think you may have commented about it earlier today. There's some green, there's still a lot of yellow, and there are one or two reds. But that's what we look at. And we try to, because when we go to Congress, when I go to Congress, they want to know much more than we can tell them, because they want a plan right now. And they want to know what the vehicles are going to look like. And we don't want to tell them that. We don't have a clue because it's too far off. We want to be able to migrate and evolve into the ultimate vehicle that takes people to Mars when we really decide it's now time to set foot on it. But still, we've got to be able to show them what we're doing. And what we try to show them with the tools that you give me is how we're gradually buying down risk. The thing I ask of all of you is don't lose faith. You know, don't be discouraged. Some of you have been coming here for a long time, and I can imagine how you feel that, boy, we had this conversation 4 years ago, and I don't see a lot of change. Well, trust me, as somebody who looks at it from way far away, there's change every single year and every single day. We're making steady progress. Every once in a while, we stumble backwards, but every single day, we're getting better. Reducing the footprint of equipment is critical for us. Getting things smaller, lighter, the handheld instruments that we use for doing diagnostics for the crew members today that used to be big instruments, those are game changers. And not only are they game changers, they are turning out to be lifesavers for people in parts of the world that have never seen that before. You know, like getting an ultrasound for an expectant mother in some doggone village out in Honduras, and the closest doctor is 100 miles away. And yet we can go in, and some of your scientists or our scientists and medical personnel can go teach a midwife, so to speak, in the village how to use a portable ultrasound so that they can look at the fetus on a routine basis, zap it back 100 miles or 200 miles, and the doctor says, don't worry, everything's okay. Or one day it says, okay, it's time to go. Put them in a cart, put them in a car, put them in whatever you can get them in, and get her in here because we need to see her. So those are really good things. Somebody asked the question this morning of the team about medication, about drugs. We are always looking at how we increase the shelf life on packaging for foods, for medication, and for other supplies. So it's really good to hear you all ask those questions, because if nothing else, I don't know about Julie, but it gives you a sense of satisfaction that at least, boy, we're at least on the right path there. We're not going off spending a lot of time and effort in something that people don't think is worthwhile. So that's the reason I say questions, criticism, comments are always welcome, because it may be something we have not thought about. This is hard stuff that we do. Establishing an appropriate and an easy to use medical laboratory for health monitoring and diagnostics on board. 8 months one way, 1 year on the surface or under the surface, whichever we choose, and then 8 months coming back, unless I do some miracle in the next few years and we get the kind of game-changing in-space propulsion I'm looking for. It's going to take us 8 months. And so we've got to learn how to operate with that as a constraint, at least for some finite period of time. And so we need to establish a way to get a small, compact, usable medical and treatment facility that's on board our spacecraft, whether we've got a doctor with us or not. Training doctors the way that we do it, crew surgeons, it's always good to be called a crew surgeon, especially if you have a daughter who's a real one. She wasn't a real one when I was my crew surgeon. She was a little kid. But as a crew surgeon, it's great being able to now call your daughter surgeon. But those are things that are really important. I kind of hinted at it when I asked Misha one of the questions. What is encouraging, but it is one of the areas where we're still falling short, is getting astronaut and cosmonaut research volunteers. Those who do deserve our appreciation. Because, I don't know how many of you have been your own subject and have allowed yourself to be poked and prodded and other kinds of stuff like that. That's not a lot of fun. And so when we have a crew member who determines that I'm going to do this, I listened to Dr. Ray Seddon when she was inducted in the Astronaut Hall of Fame last weekend, and one of the points that Ray made was she was a little weird when she came into the office, because she was one who wanted to volunteer for any and every medical experiment that there was, because she knew that somebody, we needed the data and somebody had to do it. And so by setting the example, she was hoping that more of her crew members and fellow astronauts would be willing to do the same thing. So they not only have full-time jobs maintaining station, they also volunteer for biomedical research. And to hear, Misha talk a little bit, not a lot, but a little bit about his work in LBNP, or the fact that they're now doing a lot of things that they did not do before. That's good. I mentioned this international nature. I have pushed before, and now I'm very proud to say, working very well with my counterpart, Mr. Ihor Komarov, who is the new head, not new anymore, but the head of Roscosmos. He and I both agree that we have got to get more visible collaboration and cooperation on board from our crews. Question I get all the time is, you always talk about international stuff. Why is it that we never see any video from the Russian segment? Or why is it that we never see an interview like we saw today with Misha and Scott, where they're showing us instrumentation in the Russian segment or somewhere else? And Scott mentioned the fact that one of the reasons they like being in the gym is because that is an example of the international collaboration that is the International Space Station. So if the public is asking me why don't they see more, it kind of goes back to Scott's comment about not telling our story well enough. I think it's characteristic of people in the astronaut office, believe it or not, we always feel we're not telling our story well enough. When you're a part of the story and you go out to a school and you're talking to kids, particularly today, and you go into a very, very wealthy school with some very, very smart kids, and you ask them, to tell you something about the International Space Station, and they give you this glazed over look because they don't have a clue, then you know we're not effectively telling our story. And I will remind everyone in this room, you are a part of a very tiny percentage of the world's populace that knows and appreciates what we do. We drink the bathwater because we love what we do and we're really passionate about it. But there's still about 99% of the world out there that doesn't know what we do and really has no appreciation of it. And they don't understand that a lot of things from which they're benefiting come from the work that you all do every single day. So we do need to work harder to tell our story. And that's not an indictment on our present communication systems or anything. I take it as a personal responsibility to be a better storyteller, to be a better purveyor of the story of NASA and our partner nations. So that's very, very important for us. Because Congress and people in politics in general, I hate to tell you this, they are not impressed by research. And they are not impressed. I was reminded of this in a meeting with a very prominent appropriations senator yesterday, when I talked about demonstrations that we need to do before we can do something. And I was told, look, I don't need demos. I want to see hardware. I want to see a satellite doing this or doing that. That's a fact of life. And so how do we compensate? We do everything we can to establish intermediate milestones. We try to hit them when we say we're going to hit them, and then we talk about them, and we publish them, which is very unscientific. I'm pleading with this community, as I have done for the last 40 years. Every once in a while, allow yourself to just set yourselves free and share with someone your I know this is, in a lot of your minds, this is criminal to even think that you would share a supposition about a finding based on a data point of 3, when all of us know that the maximum data points you may get is going to be 10 over the time of your research. We are a world of people who work with small data points, small n's. And so we've got to be able to make every single success that you have, no matter how small, a big deal. And not over-promising, not at all, but telling people how this relates to where we ultimately want to go. And I think that's really, really, really important. That's what I see in my workings in DC every single day. There are differences between medical care and low Earth orbit and what we're going to find on exploration missions. We've got to understand that, and we've got to figure out how we do it differently and how we do it effectively when we start moving away from low Earth orbit. And we're going to have an opportunity to do that when we get to cislunar space. We're going to be in cislunar space for about a 10-year period of time. The roadmap for the U.S. is really straightforward, and you can divide it in time chunks, in decades, or you can divide it into terms. Like, we use 3 terms. We use Earth reliant, which is where we are today, operating in low Earth orbit over and over and over again, as we've been doing for the last 50 years, with the exception of Apollo. That brief moment in time, we stepped away from low Earth orbit, but other than that, we have been Earth dependent, Earth reliant. Where we're trying to go next, and we're about 2 or 3 years away from moving to the next arena, which is the proving ground for us. And I was really glad to hear a lot of you use the term this morning, because one of the other things I learned in Washington, if I'm using a set of terms and you, the operators and the experimenters and the people making things happening, are using another set of terms, we are hopelessly lost. So we've got to we have got to get on the same sheet of music when it comes to just the terms that we use. And if roadmap isn't one you want to use, let's get together and determine what it is we want to talk about how we're going. So the second place is the proving ground, and that's about a 10-year period of time. It's the 20s. And then, provided everything's good and we are not shocked or surprised or dismayed by something that just overwhelms us, we're moving from there, and the next step is going to be into being Earth independent, and we're going to be in the Mars environment. And humans are going to stay out there for long periods of time. And some are going to choose to go down to the surface, and whether or not I always like to tell people we're going back to caves. It may be. You know, if we decide that we can't figure out a way to take care of the radiation environment and roam around on the surface 24 hours a day, we may have to go back into caves. And that is why robotic development is so important, because I'm not going to send an astronaut or a cosmonaut to dig a cave. We've got robots that can make cave habitats today. And that's what some of you should be thinking about. How do we prepare the habitat so that we can move humans into it? Just a couple other things. And you know, there are, to my knowledge, we don't have current problems with providing up-to-date medications and medical supplies and the like to the International Space Station. Thanks to the fact that we now have redundant capability to get supplies to space with Orbital Sciences and SpaceX, the fact that we lost a capability back in October, we didn't miss a beat. So we really, I mean, you knew that you didn't have two providers for a period of time, but SpaceX was able to pick up the load where until Orbital Sciences could get back. And they're probably going to fly again by the end of this year, and then one more time on an Atlas V before they go back to flying Antares and a vehicle that they're designing. New technologies are going to have to be low mass and volume. We need that when you talk about exploration, and that's what we're trying to work on. So let me see if there are a couple of questions, because I got 2 minutes. I think Mr. Abbey told me that. Yes, Brewster.
Charlie, what's the risk that an asteroid becomes Jamaica?
What's the risk that an asteroid
becomes Jamaica?
Oh, that one becomes Jamaica. Today, based on the statistical studies that we've done, the risk is near zero. It's not, nothing's zero, but the chances of a civilization destroying asteroid, something that's 140 meters, oh, well, okay.
On your circumnavigator mode,
yeah.
you pointed out it.
Oh, what's the risk? I got you. The asteroid redirect mission is hard enough. That is not going to become Jamaica. My concern is, are we going to be able to stop at an asteroid on our way to Mars? You know, an asteroid would be an incredible intermediate place for us to go do some of the operational things, not medical things, just plain old operational things that Bill Gerstenmaier will probably talk to you about them tomorrow on his panel. If he doesn't, ask him. We don't know how to, we humans, scientists know how to do it. The planetary science guys know how to operate in microgravity and zero gravity environments around other bodies. We don't know how to do that exactly, you know. I thought I knew how to do everything when I came out of being a test pilot. I remember my first day in the simulator trying to do a rendezvous where, you know, there's this thing called orbital mechanics. You don't just put the nose on the guy and fly out in front of him until you get there. Do that and you never get there. So I had to relearn, you know, how I did very basic things that I took for granted. We're going to have to relearn how we do rendezvous and proximity operations when we start operating around asteroids, or we start operating around Phobos or Deimos or whatever else it is. The planetary science guys know how to do that because they've been doing it for decades. But it's hard to translate that into human speak, if you will. We'll learn it. And so I'm not worried about the asteroid becoming Jamaica. I am worried about, you know, the asteroid not even being on the map, because there's a lot of technology development that two things that our NASA Advisory Council made it absolutely certain we must do, no matter whether the asteroid redirect mission is de-scoped or downgraded or thrown away. We've got to develop high energy solar electric propulsion so we can move large masses between here and Mars. Cargo is going by ship. It's going to go probably by, you know, on a spacecraft that's using solar electric propulsion. That may take it a year and a half to get there, but that's not important. When we send our troops overseas today, 90-some-odd% of all the supplies go by ship. They don't go by airplane. They go by ship, you pack them up, and the troops meet them where it's going. Ships move pretty fast today, though. Our solar electric propulsion vehicles don't move too fast. And we've got to learn, the second thing they told us, we've got to learn how to operate in low gravity and no gravity environments. So those two things we'll do. But it would be nice to have an asteroid out there that we could do it. NASA also has responsibility for developing technologies that are transferable to the private sector. Not a lot of other federal agencies have that mandate, and we have the mandate. And so we're constantly peppered by the administration and by the Congress because we're not transferring enough technology into the private sector. And one of the things that people want now, they want to know how to mine asteroids or how to go, do things with an asteroid. We don't know how to do that yet, so we've got to develop that technology. Everybody wants in-space refueling depots. That's great. Once we figure out how to transfer cryogenic material from one container to another without destroying the receiver because it all turns to ice, while it's going, we'll be ready to do that. But those are things that people who encourage us or mandate that we do all these things, their assumption is, we know everything, and so just make it happen. Walt.
Frequently asked, and I don't have a good answer. Why should we try to be parking an Android, for example, at Lagrange point? I never have been able to come up with a good answer.
It doesn't matter where you move it. Well, you could pick any place. The point in trying to move an asteroid or impact an asteroid or portion thereof is that one of the other mandates that we have is developing the technology to help protect the planet. And I have to keep reminding people that's not what we're doing. The asteroid redirect mission, if it is 100% successful, we've just pushed the ball down the field. We have not shown anybody how to protect the planet, but we will have demonstrated that yea verily the physics works. And you can, in fact, if you can get with an asteroid that's inbound to Earth early enough, you can affect its course such that it misses Earth, and you don't need to miss by much. So that's the purpose for that demonstration. It has nothing. My science friends say, but it's not science. I say I understand that, but that's not what the Congress and other people asked us to do. They asked us to be the technology developers for somebody down the road, whether it's DOD or Homeland Security or somebody. And protecting the planet from asteroids is not an American endeavor. It really is an international responsibility, and so. That's why we think it's really critical that we have international partners participating on it. People spend a lot of time at UN Copious and other places over in Vienna talking about this all year round, and we're just trying to figure out how to help them do that. Was there one more question, and then I got to quit?
So, Charlie, the hardest question. Why are you so optimistic that we're going to Mars when governments change, parties change, economics change, there's global warming, there's a ton of stuff going on that's destabilizing countries, and yet many of us believe we're going to Mars, and it won't be interrupted by any of that. Why do you think it won't be interrupted very much by any of that?
I think it won't be interrupted because I think you all are really passionate about what you're doing, and you're the messengers, and as long as you keep the message out there, we are the influencers. That's what we do. My job is to influence decision makers in Washington, D.C. I can't think of any time other than maybe during the Apollo era that when I go to the Hill, I don't get a single member, not a single member, at least who says anything, Republican, Democratic, old, young, it doesn't make any difference. All of them talk about going to Mars. I've not seen that before. I was alive during the Apollo era. I happen to believe, and Tom Stafford can probably give you a lecture on this, or George could, I think it's a myth that we had overwhelming public support when we went to the moon. I happened to be alive and doing things at that time, like out in the street demonstrating and stuff like that. So I was a part of the destructive part of this country that was demonstrating as a part of the civil rights movement, demonstrating, to get out of Vietnam, doing all other kinds of things. And I don't think the folk that were with me cared whether we went to the moon or not. They all stopped. They stopped dead in their tracks on the evening when Neil Armstrong stepped out of the Eagle and set foot on the surface of the moon, but so did people all around the world. In my lifetime, again, I've seen it several times. Same thing happened when Curiosity landed on Mars. The world stopped. Times Square was packed. almost like New Year's Eve. And everybody was standing in Times Square, mesmerized, looking at a cartoon of Curiosity landing on Mars, on these giant screens in the middle of Times Square. That's what we do. That's what this group does. You mesmerize people with what you do. And I think that as long as you all, you don't get discouraged. It is, trust me, I'm not an investigator. I can imagine what it's like. But I'm not one. But I really believe that we're on the right course. But you really have to stay the course. And you keep influencing the decision makers and don't let them stray. Okay? Thank you all very much. Thanks a lot.
Thank you, Charlie. Charlie, and